All right, so I'm going to show a quick demo of how to use Certisfy to project trust. That is by generating claims and to verify information. That is, you receive claims from others and you verify the information. Let's go to the list of my certificates. Certificates are what you use to generate claims. In other words, they have the information that has been verified. In this case, I'm using a certificate that has some basic identity information for me. This information has been verified and I've been issued a certificate for it. I specify for how long I want this claim to be valid. It is important that you limit this so that you don't have a cryptographic signature out there that's unlimited in terms of validity. The most important component here is the identity component because that's really what makes this whole solution trustworthy. You have to have a certificate that anchors to your real life identity. In this case, I'm using a certificate for my driver's license that represents my real identity in the real world. The important thing to note here is that the resulting claim that we generate here is not going to include my actual driver's license information other than indicating that the identity is based on the driver's license. It does not include the number, for instance. What it does is create an identity, a cryptographic identity for myself and the person in relation to the person that's going to receive this claim. So here it asks for a receiver ID, and I will show you in just a moment where to get that from. But what it does once you have that receiver ID is generate a hash between the driver's license number and that receiver ID, and that's a unique hash that's sticky. In other words, even if I were to get a new certificate, as long as it's the same driver's license number, that hash will be, and as long as it's the same receiver ID number, that hash would be the same. So it's a way for the receiver to kind of track me without necessarily knowing who I am, right? The hash is anonymous, but because of the stickiness of how it's constructed, the receiver can hold me accountable. So it's possible that I generate this claim, I give it to somebody who's say running a blog or uh, a social media service. They can store this hash without knowing who I am. If I violate their terms of service and they ban me, for instance, uh, they can hold me accountable so that next time if I generate a claim, this hash will still be the same and they will know that it's the same person, even though they don't know who that person is. So I'm gonna switch to another window that represents a different user. So this is a different browser and I'm gonna get the receiver ID. All the information in Certify is stored locally in the browser. So I'll copy that ID here representing the person for whom I want to generate a claim. And I'm gonna paste it in here. Then I'm gonna include the trust chain because this certificate that I'm using is not in the registry. So I need to attach the certificate to the resulting signature. And in general, I could have just generated a claim directly from my driver's license. It's not a good idea. Your driver's license or your social security number certificate in in most cases should really just be used for anchoring your real life identity, unless the entity that you're generating the claim for is the kind of entity that you're comfortable sharing your driver's license number with. You should never use it directly. You should use it instead along with other certificates like this one, which it does have private information, identifying information, but it's not as private, I would say, compared to your actual driver's license number. So it's something to note about the use of identity certificates is that uh, you primarily want to use them as a way to project trust, not necessarily directly. Now, there are some use cases where it's perfectly normal. Like if you're dealing with a bank and they want an ID, you can use your ID certificate directly and provide that information to them. So let's create the claim here. And this creates a claim. It's a whole bunch of information in here, including the signature. You could share this claim. As you can see, it's text, so you could email it, you could text it, uh, or using whatever other mechanism. You can also use a QR code. Suppose you're using this service as a ticketing service to access, some event. You there's somebody standing at the door and they ask you for a claim. Depending on the implementation, yeah, you can generate a claim and they can scan it. And this indicates that the solution itself is actually quite versatile. There are all sorts of ways that you could use this to solve trust related problems. So we're going to copy this claim here and then switch to this other window representing the other user. And we're going to verify this claim. So assume this was somebody who would ask me for a claim. When I paste it in here, it recognizes that there is an attached trust chain, so I'm going to accept it. Um, in general, the concern around attached trust chains is that the information is not coming directly, the certificate information is not coming directly from the registry, from the Certisfy registry. So it's possible that, for instance, the certificate has been revoked and you don't know it because you're using one that's been attached to the claim. The risk is minimal, but it's something to be aware of. You click verify, and this tells you that this information was issued on a certificate that was verified, and it has an identity associated with it. Here's a hash that I talked about. Now, if you were given this as a service provider, you could store this in a database as a sticky ID for this user. You have no idea who this user is, but you do have this sticky ID that they will not be able to circumvent as long as they're still using the same identity element in the real world, as in like your driver's license or the social security number. Of course, you can, if you have multiple IDs, then real life IDs, then you can kind of get around this a little bit, but there is a limit to how much you can circumvent this. It tells you what type of identity element was used for it, but that's it. Otherwise, you don't know who this person is. That's it. This is cryptographic proof of information authenticity, and the cryptography is happening in the browser. So the information is also stored in the browser. Thank you.